Hello viewers, this is Everyday Tutorial. Today we'll be talking about Hooke's law. Another Hooke's law we'll be talking about the energy stored in strings. Energy stored in strings. So what's Hooke's law? Force is directly proportional to what? Force applied to a body is directly proportional to the extension. And the extension, it means what? The change in length. The change in length. When you have a rope or a string, let's use a string instead. You have a string. Now, if a force is applied to these strings in the opposite direction, this string has a length before. It's the original length, which is L1. Maybe let's assume it's 2 meters. So when you apply a force on these strings, the strings tends to what? Expand. So now we now have additional length. So this length is called what? Extension, E. So the force applied to this string is directly proportional to what? The extension. That means as the force is increasing, the extension what? Will be increasing. So we have F is equals to what? KE. K is the constant of proportionality. So we can make it solve the formula, which means F over what? E. F over E. I told you E is what? L2 times L1. This is the what? L2. So we talk about energy stored in the strings. Energy stored in the string. That's when we have formula like half Fe. That's the formula for energy stored in the string, half Fe. Now, but F is what? F equals to what? Ke. So it can also be half Ke multiplied by E, which is what? Half Ke squared. Half Ke squared. So these two formulas can be used for energy, to calculate the energy stored in a string. So we treat few examples on this before we move to the next topic. Okay, so see this question. A force of 50 Newton is applied to a string of length 2 meters. The string expands, it reaches a new length of 4 meters. So the question says we should calculate the force constant and then the energy stored in the string. Now, I told you the other time, let's write out the parameters. The force is what? 50 Newton. The first length is 2 meters and the second length is what? 4 meters. So I can clean this up now. So there is a force of what? 50 Newton, which is being applied. Let's assume this is the strings. It's being applied on this string. The string is of length 2 meters. That's the original length of the string. So now this force, it draws the strings till the strings reaches a new length of what? 4 meters. So the question now asks you to calculate the force constant and the energy stored in the strings. So now the first thing to do is to get the extension, because the formula is what? F equals to Ke. So we have our force. We want to look for the force constant and we need our extension. What is extension? Extension is what? The length 2 minus the length 1. the new length minus the what? Original length. So we have 4 minus 2, which is 2 meters. So we have our extension, we have our force. So F equals to what? KE. 50 is equals to K multiplied by 2. So our K is what? 25 what? Newton per meter. 25 Newton per meter. So the unit of the force constant is what? Newton per meter, because force is measured in what? Newton, and extension is in what? Meter. So, and the second question says, well, calculate the energy stored in the strings. Energy stored in the string, I told you, is what? Half Fe, or you use what? Half Ke squared. It's still the same thing. We are going to check that out now. So using half Fe, we have half multiplied by 50 multiplied by our E is what? 2. So we have 50 joules. Energy, joules. Energy is joule. So, or if you want to use this formula, we have half multiplied by our K was 25 multiplied by, then the extension will be squared, E squared. So we have half multiplied by 25 multiplied by 4. So 2 here 1, 2 here 2, we have what? 50 joule. So this is the energy stored in the string. Is either you use this formula or you use half Ke squared. So thank you so much for your time.